In this question, R is the resistance of the material. R is the resistance of the material, and rho is the resistivity of the material. L is the length, of the conductor. Material, that is material or conductor. R is the resistance of the material or the conductor. Okay, and A is the area of cross section. A is the area of cross section of the conductor. Suppose this is a conductor. This is the area of cross section A. This is the length L. R is resistance and rho is dependent on the material, which is called resistivity. Now we know that R is directly proportional to resistance is directly proportional to the length of the conductor. If length is more, then the resistance will be more, and is inversely proportional to the area. If area of cross section is more, resistance will be less. Suppose thicker wire will have less resistance. So R is equal to some constant. That constant is rho into L by A. The small L we are taking here. R L by A. This is the formula we use to calculate the resistance of a material. Now derive the SI unit of the electrical resistivity. Rho is the resistivity of the material, which is equal to, now we can rewrite it as R into A by L. If we want to take its unit, then SI unit of resistance is ohm, and area is meter square, divided by length is meter. So the resistivity has the SI unit ohm into meter. And second bit, the resistance of the metal wire of length 3 meter. That means length is given as 3 meter. Length is equal to 3 meter is 60 ohm. That means resistance is equal to 60 ohm is given. If the area of cross section of the wire is 4 into 10 to the power minus 7 meter square, area is 3 into 10 to the power minus 7 meter square. We have to calculate resistivity rho, which is equal to R A into L. R into A by L. R is 60 ohm. A is 3 into 10 to the power minus 7 divided by L is 3 meter. Area cross section of the wire is 4 into 10 to the power 7. That is 4 into 10 to the power minus 7. That is the area of cross section. So it is equal to 4. Now you can take this as 4. Now if we will cancel this 60 with 3, then it will be equal to 20 into 4. That is equal to 80 into 10 to the power minus 7 ohm into meter, or which is equal to 8.0 into 10 to the power minus 6 ohm into meter. Third one is, state how would electrical resistivity be affected if the wire is stretched so that its length is doubled. If if the length of the wire doubled, if the length is doubled, then also rho remains constant. It is the property of the material, it depends upon the property of the material. Rho depends on the property of the material until and unless the material is changed, rho remains constant.